Hello, hello Tarık. Thank you for your attendance. You are only one student in the class. Thank you. Record. Stop recording. Okay. Okay. Today we're gonna discuss your midterm project. Also, electric drives mechanical part. Actually, to do now, you designed the DC motor, also DC motor controller, power, torque, and speed requirements. Today we will discuss the longitudinal dynamics of the vehicle. Actually, your midterm project, after that you have a 2 weeks for your midterm project, you will design electric vehicle model. What's the steps of them? Actually, it steps firstly you will design vehicle dynamic. Also, you will calculate your power demand, torque demand, speed demand, etc. You will add drive cycle for speed variation, for example, NEDC drive cycle, and then to do now, you build a DC motor model. You will connect driver model, vehicle model, and your DC model. Also, you will add the battery model. Actually, I will see end of the 2 weeks. I'm waiting from you electric vehicle basic model. Okay, this is the very moderate vehicle, yani not the advanced, actually we can say moderate electric vehicle model. Okay, I will upload your homework step by step, but the basic hints in this class. Also, I will organize 3 makeup class. Okay, don't worry about it. This is our 5th class, I suppose that. We need to design more 3 weeks. Okay, now you can see in your screen longitudinal dynamics of the vehicle. Actually, for mechatronic students knows that uh, we can think vehicle model lateral and longitudinal. Okay, actually lateral model is necessary for steering control, also road control, also rack and pinion system. Moreover, longitudinal model is necessary for vehicle power and torque needs, speed needs. Basic models for the study of your midterm project, also maybe final project, a study of the longitudinal vehicle motion include 2 main elements. Okay, vehicle dynamics and powertrain dynamics. To the now, DC motor, I said several times, DC motor is not a good motor types because it's just a basic motor. In the maybe 100 years ago, some English motor company, vehicle company design a DC motor for electric vehicle, but now we don't use DC motor in electric vehicle because it's efficiency, etc. But your first midterm project, you can use DC motor. Okay, we can agree with this situation. You will use DC motor. Actually, in your first homework, you designed the DC motor. Very simple, but it is okay for us. You have torque input, you have speed input, also you have motor parameter, etc. You can design only electric vehicle DC motor model. You can select motor parameters for example, 70 kilowatt. Also, maybe your torque will be 100 Newton meter, etc. Maybe you can add a gear. Okay. In this chapter, the external forces that influence vehicle longitudinal dynamic will be studied in this course. Aerodynamic drag, rolling resistance force, gravitational force, and longitudinal tire force. Generally, in electric drive system, we are starting with the mechanical needs. After that, we can select our electric motor and drive system. Okay, this is a very important parameter. Actually, I said you first course, we have lots of discipline combination in the electric drive system. One of them mechanical side, one of them power electronic side, one of them electric machine side, also battery side, also some some maybe we can add power electronics, auxiliary load side, etc. In electric vehicle, we can say all of them powertrain. Okay, I say again, today we will focus aerodynamic drag, rolling resistance force, gravitational force, and longitudinal tire forces. Okay, vehicle performance includes the calculation of maximum acceleration, maximum cruising speed, and gradability. To obtain these parameters, it's essential to know the longitudinal force affecting a vehicle. In your first figure, left side of your screen, you can see these forces. You can see we have braking force, lateral force, vertical force, also roll, pitch, and yaw angle in my vehicle. But I need to say yaw, pitch, roll angle. Maybe you know these are called as a Euler angle. Euler, maybe if you design a drone or a manned aerial vehicle, probably you will understand it. Yaw, pitch, and roll angle. It's meaning that not classical alpha beta coordination transform. But now, if you design steering control, for example, ABS, ESP, etc., you will focus lateral force. Lateral is meaning that in Turkish, yanal forces. In the our course, we will focus simple longitudinal force. Okay, what's the longitudinal? Longitudinal is doğrusal kuvvetler. Longitudinal force is meaning that doğrusal kuvvetler. You can see in your screen, we will calculate longitudinal axis. It is important for starting to design an electric drive system. Okay, the study of longitudinal dynamics is based on simple two-dimensional model. It's important for us. We will start with the two-dimensional model where lateral force and vertical acceleration are neglected in our study. It's if you want to design advanced vehicle dynamic, you will focus lateral force, okay. But in electric drive system, we are focused only longitudinal force, okay. Another one are neglected. Longitudinal dynamic behavior includes both traction and braking force. Maybe you can say me, we are electrical electronics. No, electric drive system is not only electrical engineering. It's combination of mechanical engineering side, mechatronic engineering side, and powertrain and forces engineering side. Okay. For example, you want to design an elevator system. You want to design a pump and HVAC system. You want to design wind energy system, wind turbine system. You want to design electric drive system. How can you calculate the power needs? How can you calculate the torque needs? For example, you can say me, uh, maybe last before 2 days, one student in your class asked me, we don't know the wind turbine speed, wind speed. Actually, you need to calculate torque demand in this application. How can you calculate the torque demands? Firstly, you need to know blade length, wind force, direct coefficient force, also blade material, etc. Firstly, we are starting with the force calculation. Okay, this is very important. After that, we will select motor type, power electronic voltage level, current level, etc. Also, and then the battery capacity, battery consumption time, etc. And then the driver profile, blah, blah, blah. Okay. However, in this course, traction forces only will be explained. We will focus traction forces. The base of the longitudinal performance of a vehicle will be the fundamental equation, longitudinal motion, where the dynamic features of the vehicle and the impact of the external environment are quantified. This will involve the evaluation of resistance. What's the resistance? Resistance, the contract movement. Okay, as a way to calculate the actual performance parameters of the vehicle and the influence of adherence on the tire road contact surface. It's main important. For example, you can think in your road, We have dry road, we have wet road, we have snowy road. Our our contract movement will be hard in this position. For example, you have a very dry road, it will be very hard. If you have a wet road, it will be very easy. Okay, we need to calculate the Newton's second law will be applied in the longitudinal direction at this position. You can see in your screen, we have total traction force, total Fx will be equal m times ax. You know the a is the acceleration at the x direction. Also m in the actually your weight. Also, if you want to calculate the total force, traction force minus resistance force, it's very simple. You know the your beginner elementary school, but now it's important. Now we will organize the resistance force. Okay, firstly, we can start with the traction force. Okay, traction force is tractive effort actually. It's meaning that tractive for effort is the force applied on the wheels at the road surface in order to move the vehicle. The available traction force is limited to two factors. Traction force generated by the drive system. We will generate it. What's the component of the generation? Electric motor and maybe we can say gear. Okay, electric motor and gear. This is meaning that drive system. Also, next one, weight distribution of the vehicle entire road. In general, the drive system limits traction capacity at high speeds, while adherence imposes a limit when running at low speeds. If you use a vehicle, you know what's the low speed at the speed and torque relationship. We are using a gear for adjusting the speed and the torque. The most restrictive condition will determine the maximum traction force. If you want to design an electric vehicle, first step, you need to calculate maximum traction force. Okay. Now, the drive system includes vehicle engine or vehicle electric machine, also gearbox and power transmission system. The ideal electric motor power torque or traction curve is presented in the right side of your screen. Okay, this is my power, torque, and speed curve. This is the ideal condition. However, internal combustion engine don't befit this behavior, and their performance is another figure. You can see this is ICE engine, this is the electric motor. Their characteristics are very different. So, why it is important? Because vehicle driver behavior, also powertrain powertrain behavior will be changed at this position. Normally, in electric vehicle, we have a flat side, and then torque will be reduced, speed will increase, and power will be constant. After that, torque is decreasing. Okay, this is you can see in your screen. Please follow my arrow. This is constant power region in electric motor. Also here, constant power region. In electric motor, we have two working point, constant torque and constant power region. Okay, with the wave to adapt the performance of IC engine to the ideal traction curve, you can see power goes to up and then below, low side, and torque is like a triangle. Its slope nearly not same. Also, ideal traction curve, you can see a gearbox is added to drive system. Generally, it's called as in Turkish şanzıman, or maybe the ZF company, they product a gearbox is added to drive system. Okay, this gearbox allows ICE engine to overlap their behavior. Actually, I see engine efficiency is very, very low, nearly 38 percentage performance. Okay, in electric machine we have upper than the 90 percentage. Okay. Also, the force generated by the engine, we can formulate it this formula. Fe will be equal me epsilon 0 times efficiency D over R. What is it? Me. Me is motor torque. Epsilon 0 transmission ratio. Transmission ratio is show us the mechanical characteristic. Generally, we have limited performance. Maybe we can say the upper than the 90 percentage. Also, efficiency D, the eta D is called overall driveline efficiency. Don't forget it. Transmission ratio, transmission efficiency, and overall driveline efficiency, also powertrain efficiency are different things. Okay. R is meaning that tire rolling radius. Okay. Therefore, the available traction effort based on engine torque is a function of the maximum torque that the motor can generate that can be transmitted to the wheels by the transmission system. You can see in your vehicle, classical traditional vehicle, this is the gear ratio, ideal traction effort, first gear, second gear, third gear, and fourth gear. It's meaning that speed and torque is in relationship, but they have complementary increasing. Okay, sorry. Yes, it's complementary increasing and complementary decreasing. Torque is increasing, speed will be decreasing. Okay. If you want to prevent it, you need to add gearbox to traditional vehicle. Although internal combustion engine characteristics are far from the ideal performance, it's important. Their use is widespread, in your roads. This is among others because of some reason. Actually, very low efficiency, but acceptable fuel consumption, low price, economical fuel for now. Maybe next year's electric will be reduced. Electric prices will be reduced. Fuel type, low maintenance. Huh? No, not low maintenance. Actually, electric machine has low maintenance because I see engine has lots of mechanical parts, gear, aluminum case, steel case, lots of maybe more than 1000 very small size mechanical parts. However, also we have environmental effect, also noise, vibration, and gas emission. So after that, we are focusing electric vehicle. New propulsion technology, actually. It is meaning that. Yes, how we can calculate maximum traction effort based on the adherence limit. The maximum permissible traction effort that can be applied on the wheels is limited by friction between road and tire. You can see in your screen a vehicle, we have a slope, we have a four tire, also we have a road, we have a friction. Tire force is quantified using a maximum coefficient of adhesion nu is called, as you can see here, nu. We can calculate nu max. Also, the limit is imposed by adherence on vehicle traction varies depending on vehicle transmission system. It's therefore different in front wheel drive, rear wheel drive, and four wheel drive. A typical model you can see in your screen now. Pitching moments and variation in the suspension system are not taken into our account. After applying the equilibrium equation condition in only longitudinal direction, the maximum traction effort is calculated by using this equation. But this is maximum tractive effort, okay? This is important for us, but we cannot calculate it in your midterm project. It is just an only knowledge. It's the tire force. F, for example, you need to know front wheel drive vehicle, rear wheel drive vehicle, four wheel drive vehicle are have different maximum traction effort. For example, you will design an electric vehicle using hub motor. Hub motor are mounted independent four wheel. You will use this equation. This is rear force, front force, rear force, and it's depend on the L. L is the wheelbase in your vehicle, etc. It's important, but now we can neglect it. It's just a knowledge. This after this part is important for us. Now we have in your midterm project, also in your calculation, we have three types of vehicle forward motion resistance. One of them, RRA, aerodynamic resistance. Second one, RR, rolling resistance. Next one, RG, grading resistance. Total motion is defined by RT. RT is it will be equal aerodynamic resistance plus rolling resistance plus grading resistance. Okay. We can start with the aerodynamic resistance. Aerodynamic drag or resistance is produced by when the vehicle runs through a fluid medium. It depends on the external air flow around the vehicle body and on the inside air circulation. Both flows create friction and pressure resistance. What's the calculation method of aerodynamic resistance? Ra. Ra is equal 1 over 2 times rho times Cx times Af times vehicle speed square. Okay, what's the Cx? Cx is coefficient of aerodynamic resistance. It is tricky point. It is depend on the shape of the vehicle body. You can see in your road, plane shape is different, truck shape is different, vehicle shape is different, helicopter shape is different, etc. Cx is coefficient of aerodynamic resistance. Okay, and then vehicle frontal area, next one. AF. I will explain it. Huh? Also, rho is air density, and V vehicle speed. The density, rho, air density, generally the density of air in the normal temperature and pressure condition. What's the normal temperature? 25 centigrade degree. And what's the normal pressure? 1.074 Pascal. Rho generally is accepted as 1.225 kilogram over meter power 3. This value varies with altitude and kinematic viscosity, but in your calculation, you can assume that 1.225 kilogram over meter power 3. Another one, AF, is important. AF is calculated according to vehicle dimension. We have a figure here. If you know the wheelbase and the height of the vehicle, wheelbase B, H, the height of the vehicle, B and H. Also, we have F. AF is calculated by the F times B times H. You know the B, you know the H. What's the F? F has a value between 0.8 and 0.85. In your project, you can accept it as a 0.8, for example. Also, in this table is important. Why it's important? You can see drag coefficient. Drag coefficient Cx actually. Cx is different for type. It depends on the type of vehicle. Typical values, for example, in trucks, we can accept it as a 0.05. Articulated vehicle and the road trains, we can accept it 0.095. For buses, 0.038. Buses with an aerodynamic profile, 0.019. And also probably you will design a conventional passenger cars. It's meaning that 0.022 or 0. Yeah, it's variable in this interval 0.035. I think you can select, for example, 0.035. Also, another one, passenger cars with aerodynamic profiles, special cars. You can regulate it as a 0.01 and 0.19. Okay, it's very important. Now we start with the aerodynamic resistance calculation. And then next one, rolling resistance. What is the rolling resistance? Rolling resistance force are due to hysteresis in the tires. This resistance counteracts thrust force and its value depends on the vehicle mass, steering geometry, profile, type, and pressure of tires, driving speed, surface, and state of the road. It's it's calculated by multiplying the normal load on the center of each wheel. In left screen of your site, you can see a formula. Here, the center of each wheel is in this with the P, P, yes, P uh, by the rolling resistance coefficient. Fr is the rolling resistance coefficient. P, normal load on the center of each wheel, whose value depends on the material and environmental factors. For example, we can define F0 and Fv are parameters that depend fundamentally on the inflation pressure. Okay, and you can see here as a power, and is an empirical factor that varies between 2 and 2.5. You can select one of them. Also, P is the vehicle weight. Actually, it's meaning that P times Fr. P is the mass of the vehicle. Fr is a parameter. Also, rolling resistance is critical. Why? You can see figure inflation pressure and coefficient of raying. You will select from this table. Okay. Rolling resistance will increase with tire flexing work, air resistance, and friction effects on the tire tread. This figure shows us the variation of rolling resistance coefficient on different surfaces. It is different for sand, it's different for medium hard soil and concrete. Okay, we will select from this table. Nearly in the webs, lots of websites will be present you this coefficient actually. However, you can select using this diagram. Also, next and the last one, grading resistance. What's the grading resistance? Actually, grading resistance is very simple. Is due to the component of the weight opposing the movement of the vehicle when driving on a surface with certain degree of steepness. The gravitational force acting on the vehicle is Rg. Rg will be equal P times sin theta. P, you know, weight of the vehicle. Theta, inclination angle to the horizontal. If theta will be higher than 0, the force contracts vehicle motion. If theta is smaller than 0, it's a driving force. Okay. Theta is usually smaller than 10 degree in normal roads, then the sin theta, tangent theta uh, being the slope expressed in the per unit actually. It's the meaning that slope. Generally, it's meaning that grading actually. If you have a slope road, for example, it's not a flat road, you will calculate grading resistance. If you have a flat road, for example, your theta will be 0, your grading resistance will be equal 0 Newton meter. Okay. Also, vehicle power requirement. Now, maybe we can talk. In order to overcome the our mentioned motion resistance, the necessary power for the vehicle will be H. H will be equal V times vehicle speed times open parenthesis P times sin theta grading resistance plus Fr times P times cos theta. What is it? Rolling resistance. And the last one, aerodynamic resistance plus 1 over 2 rho Cx AF V square. It's very easy. Now we can calculate vehicle power requirement. Okay. This equation enables to us the circulation at a constant velocity. Now you can see we have a V. However, in the road we have different driver profile. Our vehicle wouldn't be constant. In your midterm project, you will organize your driver profile. You will use driving cycle. If you open Simulink, if you write to search section driving cycle, you will see lots of regulated standard European or American or another Chinese countries, China countries, present as driving cycle profile. You will add a driving cycle. At this situation, your speed will be changed. Constant power needs will be changed. Now, I will open a last year project, for example, midterm project. Wait me. I hope you will see. If you don't see my screen, please write me. Okay. This is the last year midterm project. One of the students. I'm waiting like this one. Okay. Classical introduction. Electric vehicle system design. Firstly, introduction. In introduction section, for example, it is a wrong. It is grade nearly 70, etc. For example, format is wrong. You can see in your screen. Format is wrong because column different size. I am waiting from you all of them with the two side will be equal. Okay, you can see here. Okay. Classical introduction. Why we can design an electric vehicle, what's our aim, etc. And then you can start the part of the electric vehicle. What's the type of electric vehicle? What's the part of electric vehicle? Battery, powertrain, driver profile, vehicle, longitudinal parts, etc. And then which type of electric vehicle you selected. Okay, for example, in this project, we are going to design and simulate the battery electric vehicle. Battery electric vehicle is meaning that full electric vehicle. Define step by step. Motor, okay, good. Motor working principle, okay. Battery, falan falan. Huh. Now, what is the parameter of design? Vehicle mass. Your friend's vehicle mass 1.0 1200 kilogram. Vehicle frontal area 3. 3 is very wrong. 3 meters square. Or maybe it's okay. Coefficient of rolling resistance CR. It's selected from the diagram for good, fair, poor roads. Okay. Drag coefficient 0.7. Max velocity 180. Air density, wheel radius, acceleration of gravity, maximum slope angle, radians, gear efficiency. Okay. And then, step by step, he tried to calculate power needs. Rolling resistance force, firstly. He calculated rolling resistance as a 138 Newton. Resistance force value, he calculated its meaning that as a, it change, what's it here? While we're considering flat road. Huh, it's not a good approach. Zero will be equal zero. It's not a good approach. I am not waiting from you not a zero because your slope will be change. For example, sometimes 1 degree, sometimes 3 degree, maximum 10 degree. Okay. Aerodynamic resistance value, it's calculated as a 3.209 Newton. Also acceleration force. He defined a driver cycle like this one in MATLAB Simulink, but I am not propose you this approach. You can use driving cycle from MATLAB Simulink library. If you can write driving cycle, you can see FT75 or NEDC, etc. Okay, please use them. You cannot build your driving cycle. Please use them. Okay. Also, total force calculation, blah blah blah, FA plus FR, FG, FD. Okay. Also, now this is just then force. Okay, don't forget it. Force. And then you need to calculate power. What's the power? Power depend on the wheel radius. Okay. Power, your his electric vehicle maximum power needs 367.3 kilowatt. Also, he designed a gear. Was told to get required power, we need to suggest gear efficiency. Okay, what's the gear ratio? Gear ratio, it's selected gear ratio 1. No, he selected gear. It's gear ratio 1 over 10. Okay. After selection of gear ratio, he decided to speed. Normally, this is power. Normally, electric vehicle speed as a RPM 1.551. After the selection of the gear ratio, his motor speed will be equal 15.510 revolution per minute. Okay. And next one, simulation section. He designed a driver cycle. I said again, you will use driver profile from MATLAB Simulink. Okay. If you can search in Simulink driving cycle, you will see NEDC or FT75. And then, this is very wrong approach. Longitudinal driver. You will design your over longitudinal driver. Okay, I am waiting from you. Today's mathematical equation will be used in the Simulink. It's very, very, very simple. Okay, don't worry about it. Very, very simple. 10 minutes maximum. Okay. And then you will design a battery. Battery is a simple. You can use MATLAB battery. You can see it's only just a one element. These are scope, etc., bus scope, etc. You will select battery lithium ion. Only you need to calculate the battery capacity and voltage level. Actually, you designed the electric machine in the first homework. This is the electrical parameter. You can use only mathematical you designed, maybe you can remember you have a speed feedback, voltage output, closed loop PI controller, etc. You will design this vehicle powertrain. Parameter setup, step by step, MATLAB design, and result. Result is very important. Your friend's result is very bad. We have no axis, name, caption name, etc. Design achieve speed. It is wrong caption. Red one probably measured value. Blue one probably reference route, speed, and the battery changing. Also state of charge changing, depends on the vehicle speed. Current variation, also voltage variation, battery voltage variation. Battery voltage is meaning that it's depend on the battery state of charge. Also another design set with random inputs. You can use the random input, but I recommend you again driving cycle, summary control, and references. Reference is important. In another slide, you can see vehicle mechanical data. I hope you can see this PDF, vehicle mechanical data. I changed another slide. Okay. This is Opel Corsa data. You can see, I hope. I will check from class.
Görüyoruz hocam.
Yes, tamam. Vehicle mechanical data. For example, one student from the last year selected Opel Corsa. Okay. Opel Corsa parameter. If, for example, you can see Opel Corsa. Top speed, acceleration, also weight, transmission, blah blah, power needs, etc. It's a very hint for you. Also, cat drawing. It's not important for you. Firstly, you will start with the power need calculation using this equation. Technical specification. You can use power, tire dimension, empty mass, frontal area, wheel friction coefficient, aerodynamic. You can use this parameter, wheel diameter. Okay, and then you will present me power need calculation. Which slope? Slope will be changed. Your power will needs. For example, if you have a 1 slope degree, our power needs 28 kilowatt. If we have a 10-degree road, we need 42 kilowatts. In our midterm project, we will calculate maximum slope. Okay, maximum slope 10 degree. I am waiting from you 10-degree slope condition design. Yani your driving cycle will be in the zero slope, but your motor will be selected according to maximum slope 10 degree. Okay. Also, and then power. Power is selected as a motor selected as a 70 kilowatt. Speed 8,000 RPM. Maximum diameter. No, it's not important. It's just a tire. Output torque will be 192 Newton meter. Good. In next figure, it's Turkish, but it's not important. Same things, but I will just want to show you simulation. For example, this is a bicycle, like a vehicle. It's just a one-dimensional. We have same equation. Yes. For this is your vehicle dynamic model. You will design it like this one. This is your this is your midterm project. Okay, this is your motor. Here, power needs calculation according to longitudinal dynamics, load torque calculation, your electric machine, your also you will add speed, his will be variable here. You will add driver profile. Also, you will add a battery. In one driving cycle, you will show me how much battery energy consumed. Also, your vehicle range. Also, another power needs. Okay, like this one, you will be sent me a graph, etc. In next one, next one, our paper, classical design and manufacture of electric powertrain. What's the aim of in this project? We are designing electric motor. Firstly, we start with the power needs, and then we are continue with the electric machine design as a finite element analysis, result, electric machine, cooling system, and then magnet mounting, motor assembly, power electronic section, cooling, IGBT, etc. Neyse, it's not important now, but it's important parameter. You can use this vehicle, this vehicle technical specification: power, tire, empty mass, frontal area, wheel friction, aerodynamic wheel diameter. You can use these one. Okay. Also, I will upload today or tomorrow, step by step, but it's not important. I am explaining the all steps in this course. Okay. Today we can finish it. It's a good course. Thank you for your attendance. We have in the class three or six students. How many students? Six students. No, five students. Thank you for Ismail, Mohammed, Sameh, Tariq, Samer. Okay. I will organize three makeup class. Please follow my emails. Also, you have a 2 weeks for your midterm project. After that, I will send your final project. Okay. After that, your grade will be clear. Thank you for your attendance. Have a nice weekend, dear all. See you next course. Thank you. If you have a question about your midterm project, I am waiting in my office. You know my office. Görüşürüz arkadaşlar. Hoşça kalın.
İyi hocam.
Nice.